Okay, so here's this dealio. I'm going to try a different way for you tonight. I think this will help explain a little bit better about why last week when we were doing these, well, I'm going to try to do it a couple of different ways so that you can see, A, where the C1 and C2, why they have to be swapped around. It's another way, maybe it's even more interesting way of knowing why. But then also, I think it'll be helpful in terms of just like another way to check yourself a little bit too. Notice that if you take this top equation and take the derivative of both sides, you get this. And you're like, well, that's cool. Why? Oh, friends, because they both equal x prime. So x double prime is equal to negative x, or in other words, x double prime plus x is 0. Hey, that's a second order. Dog, r is equal to plus or minus I. Bam! Wait a minute. I know how this works. If I get a pure imaginary, I know my answer must be C1 cosine t plus C2 sine t, and I'm good to go. And furthermore, I know that if x is 0, or if t is 0, then I get C1 is equal to 2. Yeah, uh-oh. How am I going to find C2, dog? Oh, wait a minute. The recipe says y is the derivative of x. I can do that. The derivative of x is negative 2 sine t plus C2 cosine t. Stop right. Look at it. This was C1. Notice it's with cosine. And now it's down here. It's with the sine. And notice how the C2 is with the sine originally. Now it's with the cosine. If you'd have flipped them around and done like I do and put the cosines on top of each other, the C1 and C2 would have flip-flopped. And then again, at 0, the bottom equation is equal to 3, so that means this must be 3, and we are home free. Okay? Now you're thinking, well, I could totally have done that with a matrix, and you're right, you could have done it with a matrix. It would have been 0, 1, negative 1, 0. So minus lambda, right? Right. So that would have been lambda squared plus 1 equals 0. Lambda equals plus or minus I. Now I need an eigenvalue. Now, an eigenvector. Now, it's at this point, after the third time I screwed it up tonight, because I know what the answer is, I know when I'm wrong, I should be able to just, do it the easy way. So I'm going to. Home, clear. So I'm just going to type in 0, 1, eigenvectors. And that's kind of what I thought it would be. 1 and I. 1 and I on the first set, and then 1 and negative I on the second set. Okay? So because these are the same value, 0.707 and 0.707, that's just 1 and 1. That's what I'm going to use then. Now let's go back over it and look at which eigenvectors they give us first, eigenvalues they give us first, so we see which one it goes with. Not that it matters, but I'm just going to double check myself on this guy because I've messed this up about twice tonight. Oops. I know, stupid. Why don't you delete it and type the same thing back in? Oh, it's not going to like that because yo didn't get rid of the C, bruh. So I. So the first one it gave you is I. So that's cool. In other words, if you'd have plugged in I into this guy, you would have gotten negative I and 1. Oops. And negative 1 and negative I. And you need to multiply by A and B. And remember the computer said it was 1 and I. And so that's what it said. So let's see if I agree with it. So that's negative I times A plus B equals 0. Okay. Well, it said 1 and I. So that'd be negative 1 plus negative 1I plus I equals 0. And that would have totally worked. So again, it said it was 1 and I. Okay. That's my eigenvectors. Alright, so what I want to show you is this method of writing it out. So remember, we had 0 plus or minus I, which remember is e to the 0 t cosine t. I'll write it down here. So e to the 0 t, and then of course cosine t plus I sine t. Now obviously we don't need the e to the 0 right now, so I'm going to get rid of it. But what we're going to do is that's a scalar, and we're going to multiply it times our vector, and what we're going to end up with is a vector of answers. So our answer will look like this. It's going to be the cosine of t plus I sine of t. Right. But actually, I'm going to leave the e to the 0 there just for fun, just so you can see this. This is kind of exciting deal here, e to the 0 t. And then down below it, we're going to have this. We're going to have e to the 0 t, and then we're going to have I cosine of t, and we're going to have I minus or plus I squared, so it's going to be minus e to the 0 t sine t. Now, what we're going to do is we're going to break this into two pieces. We're going to look at this because it is a vector right now the way it sits. Okay, we can think of it. We could actually think of it as a sum of two vectors like this. So right now this is a 1 by 1 vector. It's just a top row and a bottom row. But we could rewrite that as two 1-row vectors. That is, we have one that we're going to have one of the vectors be the real parts, and one of them be the imaginary parts. Okay, well, the real parts would be cosine of t and negative sine of t. And again, I just put this e to the 0 t out front. In a moment, we'll have something different, obviously. And then down here. And it's at this point we introduce C1 and C2. So what we really have then is, if you think about it, if you multiply this back out, you're going to get C1 cosine of t on the top, right here. C1 plus C2 sine of t. That's my top row. And my bottom row is negative C1 sine t plus C2 cosine t. This should look very familiar because it's the same freaking problem we had a few minutes ago. Well, a while ago anyways. And so we ended up with the exact same solutions up here, which is that guy right there. And we're home free. Now, let's do another. I'm going to pause you while I get this next one queued up. It's going to have complex roots, not pure imaginaries. We're back. Alright, cool. Now, I'm going to rewrite these as y prime and x prime. I just think it looks a little nicer. And then once again, it's something a person could do is on this bottom equation, they could solve for x equals, and that would of course be negative y prime minus y, and of course that would make x double prime equal to negative y prime minus y double prime minus y prime. True? True dat, homie. Furthermore, one could solve for y. Okay. So I don't know. You could do it a couple of different. Well, you could monkey with this thing a little bit till you're blue in the face. By the way, when they both have x's and y's on both sides, it gets a little messy. But let me just show you what I mean. So if I take that top equation and I substitute in for x. So if I substitute in for x, I'm going to get negative y prime minus y. That's what x is, and I've got negative 3 of them. Yes, that's the top equation, plus 5y. And that's true. Right? Right. And here is what x prime is equal to. So negative y double prime minus y prime equals, it's going to be 3y prime plus 3y plus 5. So let's bring this over. That's going to give me 4y primes plus 8y's, and over from y double prime. Hey, this looks familiar. I made this problem up. It works. I know. And so you will find that the answer to this is r equals 2 plus or minus, negative 2 plus or minus 2i. Okay? So negative 4 plus or minus the square root of 16 minus 32 over 2. So negative 4 plus 4i over 2. There's your answer. Got it? Got it. Now, we know that means that y is equal to what? Well, it's equal to e to the negative 2t. And then we're going to have a c1 cosine of 2t, because of this fella, plus a c2 sine 2t. Right, well, that's nice. And furthermore, we know that when y is 0, x is when t is 0, y is 2. So this part would go away, that would go away, and then this would have to be a 2 right here. And that looks pretty good, right? Well, it actually gets better than that, because check this out. In order to find x, I come up here and I say, well, look, x is equal to the derivative of y, negative the derivative of y, minus y. Well, here's y. Here's y. And we better find out y prime. Well, that'd be negative 2e to the negative 2t times this stuff inside. Remember, you don't take the derivative of this the first time. It's a product rule. Plus the first times the derivative of the second, which is going to be negative 2 cosine, negative 2 sine, you idiot, 2t. Oops, but the derivative of 2t is 4. There's 2 out there, so 4. There we go. And then plus a 2c2 sine, cosine, god darn it, 2c2 cosine 2t. There we go, big idiot. Okay. All right. Now, for the sake of argument, I'm going to leave the e to the 2t off for right now, if that's okay with you. So, I want to have the negative of this guy. The negative of y prime. So, negative y prime is going to be 2. And then, so it's going to be positive 2. So, 2 times 2 is 4. Well, I'm going to do it this way. I'm going to leave the negative out front. So it's going to be, if we distribute this out, it's going to be negative 4 cosine 2t, and then minus 2c2 sine 2t, right? And then again, just forget about this e to the negative business. I'll just add those up. So it's going to be negative 4 sine 2t, and then plus 2c2 cosine 2t. And if you distribute the negatives through, that becomes positive, 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 negative. So I want this guy minus the original function. And again, ignore the e to the negative 2t for right this instant, because everyone's got one, so it's all the same. And so if I collect my like terms, I've got a cosine here, and I've got some cosine here, and some cosine here. So 4 minus 2 is 2 cosine 2t, minus 2c2 cosine 2t, right? Right. And then, oh, fiddle fart. I was supposed to subtract that, so that'll also be negative, right? Minus y. There we go. And then I'm going to get a plus a 2c2 sine. Well, minus 1, so plus 1 c2 sine 2t. And then I'm going to get a plus 4 sine t, or sine 2t. And so this technically is what x is, technically speaking. Well, when x is 0, we get y, when t is 0, y is 1. So when this is 1, And so this is 2 minus 2c2. And of course all that mess goes away because it's sine functions. So if I subtract over, I get negative 1. Add that, divide that over, I get a half is equal to c2. So this becomes minus 1. This becomes a half. And I think we're done. And then if you collect your like terms, what you'll end up with is 3, no, you're going to get 1 cosine of 2t plus 4.5 sine 2t. Theoretically, this is correct. This, yeah, probably. Okay, now remember it's e to the negative 2t out front. And we hope we didn't screw something up. Alright? Theoretically, that's true. Now, that's part I didn't check, but so we can kind of see what we think about it, though. Okay? Now, let's see. You can check yourself by doing the derivative of x prime, right? So x prime is negative 3. The derivative of x is negative 3 times x plus 5 times y. So theoretically, those are true. We'll see what happens in a moment, though. Okay? Alright, so then I found out what C2 was a half. So that's also a half. So theoretically, if I held my mouth right, this guy here and this guy here should be my two solutions. I love it when I actually do something right. So, notice up here it says that x prime is negative 3 times x plus 5y. So what I did was, in my calculator, I said, hey, let's do the derivative. So I did it. The derivative is 7 cosine 2t, and then this is e to the minus 2t. That's all that is. Minus 11 sine 2t over times e to the minus 2t. Then I took negative 3 times x plus 5 times y, and son of a gun if I didn't get a 7 and a negative 11, bro. Bam! Knock it dead. That makes me pretty happy. So, what that goes to tell me is these two equations here are the correct solutions. Now, let's do it with eigenvalues and see if we can get the same thing. Oh man, I hope we can get the same thing. So negative 3 and 5, no it wasn't. There's 3 and 5, and 1 and 1. Both negatives down here, huh? I think. We should go check though. Yes, that sounds good to me. Good for us. Now, minus lambda. So it's going to be lambda squared plus 4 lambda plus 4 plus minus, oh, plus 3 rather. Plus 5. So that's lambda squared plus 4 lambda plus 8. Hey, I've seen that before. So lambda is negative 2 plus or minus 2i. Again, if we stick those in, I'm only going to use one of them. I'll use the positive, I guess, because I guess it doesn't really make any difference, I guess. No, it doesn't. It doesn't if you don't screw it up. Okay, if you don't screw it up, that'll actually work out nice. You know, I'm going to use the negative one just for fun, I think. Because I think it'll turn out a little prettier. But you do what you want to do. I just work here for now. And then you get this and this and this and this and that and whatever. And so then you're going to get negative 3 plus 2 plus 2i, yes? Right? Right. So you're going to get negative 1 plus 2i a plus 5b equals 0. Okay, so you do this a number of ways. Again, you know, like Brandon had a pretty good idea. So I personally would do this one. This is what I do frequently, but you do what you want. If this is my a, then of course I'm going to get negative 1 minus 2i squared, which of course is negative 1. All right, plus 2, which of course is 1a. That's the way I like to do it, but you do what you want to do. I don't care. But see, if you do that, and that's fine, then that means that b is going to have to be negative 1/5 to pull that off. You see that? And whereas that's nothing wrong with that, it's just, it's kind of gross. So another person might say, and you know, Brandon might be that person, I don't know. Another person might say, well, wait a minute. Wait if we just made A that and B this. Now, does that work for us? Well, no, that'd have to be positive, right? So if I did that, this times this would be negative 5 plus 10i. And then this would be 5 minus 10i. And they would cancel out. And so 5 and then 1 minus 5 and 1 minus 2i seem reasonable. Now let's go see what the calculator gives us, because of course we're going to be doing this on a calculator quite a bit because they just get too messy otherwise, and you could spend literally hours screwing with them. And so that's not really what I want. What I would like for you to find is to find them and do something with them. That's kind of the whole point of this class, is not to do algebra. Bam. So you're like, am I right? Am I right? Well, you are, because, you are, because 0.18 goes into 0.91 5 times. So that's top one is 5, this is a 1, and of course that's a 2 right there. Now you're like, but that's positive 2i. I know. Come over here, dog. Bam. Because it always gives the positive one first, we use negative 2 minus 2i. That's the one we did. So this is a perfectly acceptable one. Mine would have worked just as easily, except it would have been gross because it would have been 1/5. So, remember, our equation is going to be e to the negative 2t. We got a cosine of 2. Yes, a cosine of 2t. And an I sine of 2t. Right? That whole thing right there. And we're going to multiply it by our vector, which is 5 and 1 minus 2i. So if you do that on the top row, you will end up with 5 e to the minus 2t cosine of 2t. And then you will end up with a 5 e to the minus 2t I sine 2t. On the bottom, you will end up with a 1 e to the negative 2t cosine 2t plus an e to the negative 2t I sine of 2t. And then negative 2i goes through there, so minus 2i e to the minus 2t cosine of 2t. And then a minus 2i squared e to the negative 2t sine 2t. And I think we're finally finished. So notice that everybody has an e to the 2t in front. That's totally true. So I'm going to bring that out front. And I'm going to rearrange these into two vectors. The real vector and the imaginary. So this one's going to be 5 cosine 2t. And then down here, real wise, I'm going to have a cosine of 2t. And this is I squared, so that's negative 1, so positive 2 sine 2t. So we get rid of him, and we get rid of him. Cool. Now on the top, of course, imaginary wise, we've got 5 sine 2t. And we end up with a sine of 2t and a negative 2 cosine 2t. Okay? Alright, we good? That makes sense? I think that sounds good, right? Now remember, where were we when we did this last time? If you come back over here, it was at this not there. Here? You see it was at that juncture right there where we added the C1 and the C2s in. So let's go back and play that game. C1 and C2. That means across the top I end up with 5, C1, right? And if I want to write this all the way out, I can totally do that. I'm just going to go ahead and do it, I guess. Ugh, what a mess. All right. So what are my coefficients? What are my initial conditions? Hey, they're not on this page. That's why I can't find them. 1 and 2. So there, my initial conditions are 1 and 2. So plug a 1 into the top guy. Well, that means C1 then right here has to be 1/5. Oh no, you didn't. What if Mr. Green would used his 1/5? What would have happened right there, bro? My C1 would have been 1. Because 1/5 times 5, check it, would have been, that's right, 1. Just like it is right now. Everywhere there's a C1, I'm going to drop in a 1/5 because that will be true everywhere we go there. This is going to be 2/5. And it's nice if everything works out, of course. That's kind of important. Now, it says that y of 0 is 2. Oh, okay. Well, if y of 0 is 2, that means 2 is equal to... Well, this cosine piece isn't going anywhere, but so it's going to be 1/5. And then this cosine piece over here is also going to be left, so negative 2c2. Now, if you add that over there, you're going to get 11/5 is equal to negative 2. And then so it's going to be negative 11/10. Now, if we cross our fingers and hope for the best, because I'm like, I'm not sure if we made a boo-boo because it looks a little messy-ish. So I'm going to negative 55/10 in here. Okay, and we'll see, if we can figure out where we went wrong. Nice. So if we add up our cosines, this is 22/10. This is, oh, fiddle faddle. Ah, hippie. This is 2/10. This is me 24/10. Cosine 2t. And then it's going to be, this is 4/10, so minus 7/10. So we're close. We are close, friends, but we're not quite there. So we're off just a skosh. So we'll see if we can figure out right now where I went wrong. Of course, there's still an e to the negative 2t floating around in that mess. Okay? I could pull it out front like that, or I can do whatever I wanted to. Okay, now, let's see if we can figure out where we went haywire. Found it. Of course, you probably saw it a while ago. Why I didn't see that sooner is beyond me. I went up here and redid it. And you're going to take this negative times this guy. You're going to get negative 2i squared, which should make this a positive 2i. Or positive 2. And, oh, I did. I put it right there. Okay, we're good. So, okay. So that wasn't the whole problem then. Okay, never mind. Never mind. All right, I think I figured it out finally. I'm back here where I got to again. I'm going to minus 1/5 this time. And so this is 10/5 minus 1/5 is 9/5, you big dummy. And so that means that this is equal to this, which means that this is negative 9/10. Okay. Now, I'm still not sure I like it, but I like it a little better than I did a minute ago, I think. Now let's see what happens here. So if you plug these in up here, if you plug in 9/10 right here, you're going to get, well, the 5 cancels, you get 9/2, which that looks vaguely familiar. And then if you plug this in here, you're going to get minus 9/10, which I'm not sure that looks familiar yet, but it will in a minute, I think, when we get some stuff cleaned up. And then 2 times 9/10, but it's going to be positive times, it's going to be positive 18/10, I guess is what I'm going to write it as. Okay, I think it's going to work this time, finally, maybe. Okay, so let's add up our cosines. So this is 2/10 plus 18 is 20/10, which is 2 cosine. That makes me happier. And then this is 4 minus 5 is negative 5/10, which is negative 1/2. Sine 2t. I'm not sure that's right, but at least it sounds more better than it did a minute ago. And yes, hot freaking dang, people. Judas Priest, that took a while. Okay, so feel pretty good about it? Yeah, I think I do. I think I feel pretty good about it, finally. Whew. Now remember, don't forget your e to the negative 2t. But for all intents and purposes, when you're doing of zeros, those cancel off anyways. So just clean it, get it away, clean it up, make yourself happier.